Everything around us is made out of matter. It is any substance that has mass and takes up space by having volume. Matter's opposite is antimatter, which is so powerful that it could power a whole New York City for a day, but it's so unstable. For the past couple of years, we have learned the three states: the solid, the liquid, and the gas, but little did we know there are actually five states in total. There's this thing we call the plasma and the BEC, or the Bose-Einstein condensate. In this video, I would show the movement of the solid and liquid and the gas, and I would also show some additional information about the plasma and the BEC. Here we have five states of matter organized in a manner according to their temperature. Here we have the BEC as the lowest in terms of temperature and the plasma in terms of highest, which here we have the solid, the liquid, and the gas in between. The logic here is because the BEC occurs at very low temperatures. That's why it's in the lowest. Plasma, on the other hand, can be found at the other side. It is an ionized gas where sufficient energy is provided enough to free electrons from atoms. It happens due to ionization. It makes up hot stuff in our universe, such as the core of our stars, the stuff of our sun, supernovas, flames, lightnings, auroras, and lasers. Fun fact, if you microwave two grapes or two water beads, it can provide these things that we call plasma. It creates plasma because as the two grapes or the water beads touch inside a microwave while microwaving, it produces a very strong electromagnetic field, and if that very strong electromagnetic field spark, it would be very hot and would create plasma. Now let's go ahead to the main topic of this video. Solids have definite shape. It has the lowest kinetic energy because the particles are close to each other. It means that it doesn't really vibrate a lot. Unlike the liquid and the gas, that the particles are far apart from each other, the solid's particles are intact. They're close to each other. That's why the kinetic energy is low. Here is what the particles look like, and here is how they move. Let's visualize that these molecules are these orbits. Notice that when it was shaken, there was very little movement as the molecules were compressed or intact with each other, and thus making it hard to move. Liquid, on the other side, has larger kinetic energy than solid because the particles are farther apart from each other, unlike the solids. In liquid, the particles can move past each other and vibrate larger. It has more kinetic energy than solid. In terms of temperature, liquid is in between solid and gas. Here is what it looks like. Compared to solid, we can see that liquid has larger movement. It can vibrate larger, has more kinetic energy, and can move past each other. And gas has the highest kinetic energy because the particles are far apart from each other compared to the solid and the liquid. The force acting on the particles of the gas are very weak because the particles are far apart from each other. That is why there will be a weaker force of attraction. Note that in gas, it has the weakest force of attraction, while in solids, it has the strongest force of attraction. Or in terms of kinetic energy, gases have the highest kinetic energy, but in terms of the force of attraction, solids have the highest. Here is what the particles look like in orbits. Notice that particles are far apart from each other. This is why there is higher kinetic energy, because there is no definite shape. So the force acting on the particles is very weak. and thus having high kinetic energy. Now we can see at the other side of the chart is the BEC, or the Bose-Einstein condensate. It is the opposite of plasma, considering it's cold and plasma is hot. It occurs at ultra low temperature. Examples of these are superatoms and the stuff that we use to preserve the dead, which is liquid helium. It is a gaseous superfluid formed by atoms cooled to temperatures very near to absolute zero. Normally, we'd have these dots, these atoms, but in the Bose-Einstein condensate, when the particles go through ultra-low temperatures, each one of these atoms would start to display wave-like properties, wherein they would turn into these wave packets that move around. As the temperature goes lower, the size of these packets would get longer, and if they get cold enough, they would start overlapping. They have what scientists calls an identity crisis because they don't know who they are, what they're doing, and where they are. And lastly, plasma. Plasma is the opposite of the BEC. It is formed when an electron is stripped off from an atom. In conclusion, why should we study this? We should study this because simply everywhere around us, everything, even ourselves, we are all made out of atoms. We are all made out of atoms and molecules, and that is what keeps us and the world intact. As said, chemistry is the study of atoms, nature, matter, and the physical composition of the world. We are, as human beings, are made out of matter, and since the study of these particles define chemistry, then we are chemistry. Our physical bodies and the world around us is chemistry. And what better way to understand the world around us is to study chemistry.